welcome to Science Cube YouTube channel. Let us discuss about introduction to graph theory. So what is graph theory? Graph theory, it is the branch of discrete mathematics. And in this graph theory, we have to study about relationship between objects. This one we should be call it as a graph theory. Graph theory, it is the branch of science, and here we should be learn about relationship between objects. So for example, this is one graph. For example, this is one graph. This is we should be call it as graph. This is also we should be call it as graph. The relationship between this one we can study, that one we should be call it as a graph. Okay, let us see the definition of the graph. Okay, the definition of graph is a graph that is G. It will be denoted by the G. So graph, it should be containing vertices and edges. Okay, G is equal to V comma E consists of set of objects V, that is V1, V2 up to Vj, called vertices, and another set of E is equal to E1, E2 up to Ek, that one we should be call it as edges. That this one we should be call it as a graph. There are number of definitions are there. So second definition is a graph G is collection of vertices and edges represented as G is equal to V comma E, where V is a vertex or node or a point, E is the edge or a line. So third definition is a set of G V comma E, where V is the set of vertices and E is the set of edges, is called a graph. That is G is equal to V comma E. V is V1, V2 up to Vn, E is E1, E2 up to En. So the all three definitions are there, no? The meaning of all three definitions are same only. So let us see, for example, which one we should be call it as a graph. For example, this points is there, no? This points we should be call it as a these points we should be call it as a vertices. This is vertex 1, this is vertex 2, and in between whatever the line is there, no, that one we should be call it as a this one is the edge. This is the vertex, this is the edge. Okay, for example, another one, we can make it square. In this square, how many vertices are there and how many edges are there means the one vertex we should denote it by V1, V2, V3 and V4. Okay, so how many vertices are there here? There are 4 vertices are there. And how many edges are there? There are 3 edges are there. So we can write it G is equal to vertices. V of V is equal to V1, comma V2, comma V3, comma V4. It is the set of vertices. Next, E is equal to of E1, E2, E3, comma E4. This is the set of edges. So one graph, it should be containing set of the vertices and edges. That one we should be call it as a graph. So for this example, we should be write it as V is equal to V1, comma V2, and edges E is equal to E1. Okay, the graph that should be containing the set of vertices and edges, that one we should be call it as a graph. Okay, the all three definitions are there, no? There are different definitions, but the meaning will be same. Next, we should be go for the example here. How we can denote G of V comma E. V is the vertices, E is the edge. Okay, V is the vertex, E is the edge. If they have to given 2 comma 1, how you can draw the graph of this one? There are 2 vertices are there, 1 edge is there. So first we should draw the 2 vertices. These points we should be call it as vertices, and 1 edge in between. This one is the 1 edge. So this one V1, V2, this is the edge, that is E1. Okay. For example, they have to given 4, 4. How you can draw this one? 4, 4 means 4, 4 means you have to draw first 4 edges. 4 vertices. So 4 vertices and 4 edges. This is V1, V2, V3, V4, and E1, E2, E3, E4. Always you should be right in a order. Okay, not a random zigzag case. Always we should be right vertex and edges in the order form. V1, V2, V3, V4. Okay, if we should be start with V1, V2, V3, V4. If we are writing V1, V2, V4, V3, that should be a wrong. That should be not a graph. Okay. For graph, you should be writing V1, V2, V3, V4. Here also V1, V2. If we have to take graph of 5, 5, there is what is the structure? What is the graph we have to get? 1, 2, 3, 4, 5. There is 5 vertices we have to draw. Now we have to draw the 5 edges. 1, 2, 3, 4, 5. This is V1, V2, V3, V4, this is V5. So how you can write it this one? E1, E2, E3, E4, this is E5. So if you have to write like this, V1, V2, V3, V4, V5, this is the correct order. Or you can write it V1, V2, V3, V4, V5. Okay. If we have to write V1, V2, V4, V5, descending, that is not a correct order. You should be writing order only. Okay. I hope you will be understand the definition. Next, we have to go for the. Hope you will be understand the definition of the graph. Next, we have to study about graph terminology and basic terminology. First, we have to study about the null graph. Let's see the definition. Graph consisting no edge is called it as a null graph. It means that we can, using one example, we can find it. So null graph is nothing but it will be not containing any edges. It will be not containing any edges. Null graph is only containing the vertices. Okay. So this one we should be call it as null graph. For example, so G of this is the vertex. Okay. This is the vertex. So this is the null graph. It is not containing any edges. For example, G of V1, V2, which is not containing any edges. So this is also be a null graph. If G of V1, V2, it is containing edge. So it is not a null graph. So null graph is nothing but it is not containing any edges. It is containing only vertices. So that type of graph we should be call it as a null graph. Okay. Next we have to see about trivial graph. What is trivial graph? A null graph with only one vertex is called it as a trivial graph. So just we have to see about the null graph. Null graph, it is containing number of vertices. There is no problem. But in the trivial graph, it should be containing only one vertices. It should be containing only one vertices. That type of graph is called it as a trivial graph. For G of V1, it is null graph also, and it is trivial graph also. G of E. Okay, so this is a trivial graph. The condition of trivial graph it is only containing only one vertices with no edges. Only vertices are present, but how many numbers of vertices? Only one number of vertices with no edges. That one we should be calling it as a trivial graph. Next we have to see about finite and infinite graph. A graph containing finite number of vertices and finite number of edges is called it as a finite graph. It means that already you know about the finite and infinite, isn't it? Finite means it is countable. Yes or no? Finite it is countable. Infinite it is uncountable. Finite it is countable. Infinite it is uncountable. For example, g of 1 comma 3 if they have to given. So we can draw this one. This is one graph. Okay. This is one graph. If uncountable, if g of 2 comma 1 they have to given. How you can draw it this one? With two edges, two vertices with one edges. Yes or no? If they have to given g, if they have to given g is equal to, they have to not given numbers. If they have to given like this square, it will be containing v1, v2, v3, v4. So g of 4 comma 4, that is e1, e2, e3, e4, that is g of 4 comma 4. So we can able to count it the edges and vertices. So that this type of graph we should be calling it as a finite graph. Okay. Uncountable. How the uncountable graph? So how we can write it? It is in the set means g of v is equal to v1 comma v2 comma v3 comma v4. Like this we can write it. Edges e is equal to E1, comma E2, comma E3, comma E4. Like this you can write it. Okay. So this is countable. That's why this type of graph we should be calling it as a finite graph. Infinite graph. Infinite graph that is uncountable. How the uncountable? For example, this is one graph. This will be a dotted line. And so on. So this will be containing, this is V1, V2, V3, V4, this is V5. This is E1, E2, E3, this is E4. This is as so on. So how we can write this one? G of V is equal to V1, comma V2, comma V3, comma V4, comma V5, as so on. This is uncountable. Okay, there is no end. E is equal to of E1, comma E2, comma E3, comma E4, comma E5. That is and so on. So this type of graphs is called it as an infinite graph. Finite graph that is countable, infinite that is uncountable. Okay. Next is order of the graph and size of the graph. So let's see the first definition. The number of vertices in a finite graph is called it as order of the graph. So order of the graph is denoted by n, that is n is equal to summation of p, that is coordinately of the vertex set. The definition, another one is it is the definition of order of the graph. It is the definition of size of the graph. What is the definition? The number of edges present in a finite graph is called as size of the graph. So the size of the graph is denoted by n. M is equal to E, that is coordinately of the edge of the set. Okay. So how we can understand this one means? So first we should be understand the order of the graph. Okay. First we should be understand order of the graph. So order of the graph, this will be denoted by n. N is equal to mod of v. This is the coordinately set of the vertex. That is the order of the graph. Okay. Next is size of the graph. So size of the graph, it is denoted by small m. That is mod of e. It is coordinately set of the edges. Okay. Let's see. Let's understand with one example. Okay. G of 3 comma 3. So you should find the order as well as size of the graph. So how you can find it? Order and size of the graph means here first we should draw the graph. How many edges, how many vertices are there? It is the vertex, this is the edge. There is 3 vertices are there. Okay. 1, 2, 3 and edges are 3. This is V1, V2, V3. This is E1, E2, E3. So, first we should be find the order of the graph. Next we should be find the size of the graph. So, order of the graph that will be denoted by n. So, how many vertices are there? 1, 2, 3. So, order of the graph it is 3. And how many edges or how to find the size of the graph that will be denoted by small m. By finding the edges we can find the size of the graph. How many edges are there? There is 1, 2 and 3. So we can find the order of the graph and size of the graph. So order of the graph, just remember it, that will be the vertices, and size of the graph, that will be the edges. Let's see another one example, that will be the g of 4 comma 4. G of 4 comma 4. 1, 2, 3, 4. Okay. This will be V1, V2, V3, V4. This will be V1, E2, E3, E4. So here n and m we should find it. N is the order of the graph, m is the size of the graph. So order of the graph is V1, V2, V3, V4. So how many vertices are there? 4 vertices there. So order of the graph will be 4. Size of the graph is, how many edges are there? E1, E2, E3, E4. There is, okay. So let's see another one example. That is g of 2 comma 1. 2 vertices, 1 edge. So here order of the graph is, that is n is equal to V1, V2. This is E1. So order of the graph is 2. The order of the graph, it will be, only we have to find the vertices. And size of the graph, only we have to count the edges. That is m is 1. The order is 2. Size of the graph is 1. I hope you will be understanding. So let's see next one. So here note, order and size of the graph are defined only for finite graphs. For an infinite graphs, order and size are not defined. It means that just we have to see the finite graphs. It means that just we have to see the finite graphs. This is the finite graph. Okay. For this one, we can able to find the order and size of the graph. Okay. This is order is n is equal to 4 and size is also m is equal to 4. For this one, this is the infinite graph. For this one, we are not able to find n and m. This n and m only applicable for finite graph, not a infinite graph.
Like, share, and subscribe.